Turn this on. Yeah, so again, I'm usually fairly loud anyway, but you'll see. Wow, good turnout. Nice to see some people that I haven't seen for a long time, and some new people as well. So really exciting. I was preparing this today. The reason I was preparing it today was because I've been off sick for about 3 weeks, so it's a bit of a rushed job, so be kind to me. But that said, I was preparing this today, and when I prepare talks, I usually like to start off and I write down what's the message that I want people to take away from this talk. And so rather than put a slide with bullet points in, I thought I'd take a screenshot of my editor, and this is a little bit which says, so this is the message I want people to take away. The message I want you to take away, and there's more message than this, but this was my first cut. Managing your infrastructure using Chef will make it more reliable, more repeatable, easier to manage and hand over, more scalable, and will allow you to focus on other potentially more interesting or more valuable projects. What has this got to do specifically with Solaris? Well, I'll unpack this a little bit. But Chef is a tool, which I'll talk about in just a moment, which has been around for 2 or 3 years, but only really recently has it been a viable option for managing Solaris systems. And that is kind of my job. What I do is concentrating on making Chef awesome for Solaris. So Opscode, who are the company behind Chef, are completely committed to Solaris being a first category resident within their world. So there's a lot of time and effort going into doing interesting stuff with Chef on Solaris. And one of the things that would be great would be to get feedback from you saying, oh wow, yeah, this sounds like something we could use, but it would be great if it did insert something here. So at that point, in the presentation, if there's anything you want to interrupt or question or heckle, please go ahead. We won't necessarily need questions at the end. Anytime, just stop me and say, oh, rubbish, why? Go ahead.
Which versions? Are you looking at specific version of Solaris or any?
All versions of Solaris from 9, 10, and 11 on Spark and Intel are supported. Yes, we are supporting Solaris 9. Lots of people still use it. Okay, so who's the messenger then? I'm the messenger. So I've been a Solaris sysadmin for a jolly long time. First got involved with managing mail servers and various other bits and pieces in the 90s. I'm a Ruby programmer. I mention that because Chef itself is largely written in Ruby, so that is of relevance. I've been involved in managing Solaris-based internet infrastructures at some scale across various places. So I've been involved in Diageo's rollout, British Gas, House.co.uk, a large number of the Motorola platforms, and some big US customers as well. So I'm kind of, I know I once said a couple of months ago, if you cut me, I kind of bleed Solaris. I'm a big fan of Solaris. I founded a company called Atalanta Systems 6 years ago. It's a consultancy which is based around solving people's hard problems, and we try to use Solaris-based stuff, and we're also very interested in using automation technology to make people's lives easier. So I'm still the principal consultant of Atalanta Systems and the non-executive director, but I've been working with Opscode since March 2012 with a specific remit to enhance Solaris support throughout the Chef ecosystem. So that's who I am. If you're interested in speaking to me or asking me any questions after the event, I'm at Lord Cope on Twitter. You can email me at my Opscode email address, sns@opscode.com, or you can email me at my Atalanta Systems address, stephen@atalantasystems.com.
Quick one, Stephen.
Yes?
When's the book coming out? The new one?
Well, there is actually 2 new books.
You're right.
So my first book is called Test-Driven Infrastructure with Chef. I'll talk about that a bit later. The second edition of that is coming out really soon. It's 95% finished. It just needs to be edited, and then it will come out. So that should be very soon. The next book, the big book, Chef: The Definitive Guide, my editors don't have a publication date for that, but it's underway. As soon as possible is the answer. Okay, so what's Chef then? What on earth am I talking about? If you start to think about what we do, and I'm assuming that most of the people in the room are involved in managing IT infrastructures in some capacity. Either they're learning about it, they're about to start doing it, they've been doing it for generations, or they work with people who do that. And what we're doing there is we're fundamentally enabling people's businesses. And if you look at somebody's business, it's fundamentally about applications. If you look at it in a certain way, your entire business is a large and very complicated application with a lot of intermingled bits and pieces. So these applications are fundamentally supported by some infrastructure. You can't run applications, you can't run your business without some infrastructure sitting underneath it. So when we are dealing with Chef, what we're actually trying to do is we're trying to shift the way you think about managing infrastructure away from, I have a server that I'm going to log on to and I'm going to manage, and expand your view to start thinking about the entire application infrastructure as a kind of organic, homogeneous whole. So the whole idea here is that infrastructure is an abstract concept, but it has a very specific technical meaning. So when I'm talking about infrastructure, for the case of definition, what I mean is a collection of resources. So if I were to sit down with you and say, tell me about your application, what does it do? If you were going to give me some instructions to rebuild this, what would I need? And you'd start to talk about things that I would identify as resources. You'd say, well, there are 7 nodes in the infrastructure. There are some floating IP addresses. You need to install these packages. There's a configuration file here. You need to make sure that this directory is in place, and it needs to be linked over here. So this whole set of resources can span networks, can span multiple machines. And fundamentally, resources are simple things that we deal with every day as a system administrator, things that we recognize. So these resources act together in concert in a very specific way in order to provide a service. That's it. That's what the whole thing is about. An application infrastructure provides a view of all the component nodes and their attributes that is necessary, and all the information that needs to be shared across all of these resources in order to provide a service. And fundamentally, that's what it's all about. When we're delivering applications and managing applications on our systems, we are providing a service. And the interesting thing about this service is that it evolves. As a service evolves and changes, it becomes more complicated to manage. And the risk of it going wrong, or the risk of somebody who manages it suddenly leaving and people suddenly being a little bit afraid because they don't understand what's going on, all of these risks start to grow. So let's have a look at this. I'm going to try to illustrate this. So here's a node. It's an application. It runs on a single machine. Okay? How many of you have ever sat down and gone into a place and said, oh yes, the application runs on the server. That's fine. Great. Or maybe you've worked in a kind of environment where you're a startup and you started writing an application and your idea is pretty good and you can stick it on a single machine, a single zone or a single virtual machine somewhere, and it works specifically on one box, and that's fine. But after a while, you maybe come to the point where you think, well, I need to scale this a little bit. Maybe there's some contention around the way the database is running, so you know what? Let's split this out a little bit. Let's actually have a separate database. So then maybe somebody comes along and says, well, hang on a minute, you've got a database, but the database is really pretty important. What's going to happen if that database breaks, or what? Maybe you want to split reads and writes between 2 things, so maybe then you start to add another database. And then another person comes along, or maybe you're sitting down, or you're having a chat with somebody at SolarisSIG. I'm not allowed to call it that anymore, am I? And they say, well, you know what? You've already got some redundancy in the application in the database tier, but you really need some application redundancy as well. So maybe you add another one, and that's fine. Then somebody says, well, that's a bit dumb, isn't it? You're going to need a load balancer, and maybe we'll need another application server. The application is very successful. You start to measure performance, and you think, you know what? We're going to need a few more application servers, and now we're going to need a couple of load balancers. Okay. the system becomes more advanced and people start talking about memcache or various other mechanisms, and you start to put extra caching layers in. And all of this stuff, which has grown really quite rapidly, to now, what's that, 11 nodes from 1, this is getting to the stage where it's fairly complicated. And this is all stitched together with configuration files. And now if I were to write for you a wiki page which says, this is how to manage this system, or this is how to build it, and you were to look at it, it would be really quite a mess. And I don't know whether you've ever been in an environment where there's documentation which describes something which frankly is as simple as this, but also has this degree of complexity. The documentation dates, it becomes problematic, and it's all kind of very, very highly complicated and very, very difficult to capture in just a few sentences. And if there's one person who fully understands how it works, there's a very real danger that they can hold the organization to ransom because they know how everything works. But of course, this is just one example. And maybe you work in an environment where you've got lots of different customers or lots of different platforms, or maybe you're a contractor, or maybe you do other such things, and suddenly you've got something completely different. Because, I don't know, it's your application. You know how your application runs, you know the best topology for it, your application is entirely unique, and so is your infrastructure, and they evolve in a manner of symbiosis. There's a symbiotic relationship there. So when you come to your systems, you bring information and understanding and context, and so does everybody else who works with them. Now this complexity can continue to grow, because now we're thinking, well, maybe I heard about this NoSQL stuff, and that sounds pretty hot, I'll have some of that, please. Oh, and now actually, yeah, I went to a Pacona training course, and I spent a lot of money, and now I want to have some really highly capable database stuff. And then suddenly you start thinking, well, you know what, we need to run this across multiple data centers. This is getting to be a really big problem. And it's a problem which is dealing fundamentally with configuration. So, configuration management is one approach to tackling some of this complexity. So you need to manage the configuration of all of this stuff in a way which is, going back to what was my message, it's repeatable, it's scalable, it's easy to hand over, it's reliable, all those kind of qualities. Now, I am going to stick my neck on the line here and cue the arguments. I do not believe that golden images are the answer. Okay? Golden images are a very, very common thing, especially in the enterprise world, especially people who come from a blade environment. And actually, as Solaris admins, the idea that we can just have some zones and we can just do a snapshot and move them across, we can do that too. But this is actually not necessarily the right way of going about it. And to be pithy, gold's kind of heavy. It's not very easy to carry around, and after you've carried a lot of gold around, your arms are a little bit tired. It's not actually that easy to mold into the shape that you want. And it's very, very, very easy to lose your configuration detail. Cloning and snapshotting. I will be as bold as to say this does not work at scale. So, there are some very notable exceptions where this happens a little bit. But increasingly, especially in a cloudy world, this is becoming more and more problematic. And let me give you a simple example as to why I think this is. So here's a boring infrastructure. So we've got some monitoring capabilities along the top. We've got a Java application, we've got some memcache bins, some database stuff. Again, fairly uninteresting. So somebody comes along and says, right, policy change time. Running SSH on port 22 is done. Let's put it on 2022. You must do this. The security bots have said so. Go ahead and do it. Okay, fine. We're talking about 6 golden image updates, okay? 1 for the Graphite, 1 for the Nagios, 1 for the generic JBoss one for Memcache, 1 for Postgres, and 1 for the Postgres master. When actually what we're doing is we're editing a file. 1 line in 1 file. But that's okay, it's cool. We will make 6 golden image updates. Now we've got to replace all of those instances, okay? So we've got 12 instance replacements. We're going to delete them, relaunch them, repeat.